In this video for section 13.2, we're going to talk about a new test called the chi-square test for independence, or minitab will call it the chi-square test for association. Now this is quite different from the chi-square test for goodness of fit. It's used in completely different situations. The only similarity is the name chi-square. So we use the chi-square test for independence if we want to test claims about whether there is a relationship between two qualitative variables. Remember that there are two types of variables, qualitative and quantitative. This was something that we saw all the way back in chapter 1. Qualitative variables are categories, and quantitative variables are numbers with units. So we are using this chi-square test for independence for testing for a relationship between two qualitative variables. The null and alternative hypotheses will look like this. The null hypothesis is that the two variables are independent, or in other words, there is no relationship there. And the alternative hypothesis is that the two variables are not independent, or in other words, there is a relationship there. So let's look at an example with this business application problem found on page 511. We have a photo business that makes its business taking photographs for college yearbooks. And they hired an MBA student to develop a survey. The survey asked about the photography and publishing activities associated with the yearbook. And one question that they had is they wanted to know whether college funding source and gender of the yearbook editor were related in some manner. So whether the college was a private college or a state college, and then the gender, male or female, of the yearbook editor. So we have a contingency table for these two variables, and it's shown here. And we want to know whether there is a relationship between the two variables using a 0.05 alpha or significance level. So we have the data here, and you can kind of see from the numbers that it looks like there might be a relationship there. It looks like for private universities, the majority of yearbook editors are female, whereas for state universities, the majority of the yearbook editors look like they are male. But we want to use statistics to be sure about this. So what we're going to do is go to minitab, and what I need to do first is enter this little table into minitab. So I'm going to do that here. Now, when I enter the table, I'm going to use the headings that I have here, so gender, private, and state. And then for my rows, we have male and female. And for the private universities, we have 14 males and 141 female editors. And for state universities, 43 male and 23 female editors. Now, I'm not going to enter any totals in this table. So notice that my table here has the totals for each column. And then it also has the totals for each row over here. So these totals I am not going to enter when I put this in minitab. I'm only going to enter the rows and columns that contain the different categories. So there's my table. Now what I'm going to do is go to Stat, go down to Tables, and go to the chi-square test for association. I'm going to change this drop-down menu to summarize data in a two-way table. And now first, I want to select the columns containing the table. So this is going to be all of the columns that contain numbers in my table, or all of the columns that contain the data itself, not the labels. So private contains number of editors in the private school, so I'm going to select that, and I'm also going to select state. Now for labels for the table, under rows, I'm going to select the column with the row labels. That's the gender column. So if I go back to my original table, I'll look at it here, but the gender column contains the row labels of male and female. So I'm going to select that and put it in the rows box. Then I'm going to click OK. And here are my results. So first it's going to make the table for me. So sometimes it's helpful to look at this, especially if you think something went wrong, to make sure that it's making the table correctly. And I see here it also puts the totals in the table for me if I wanted to know that information. And then if I scroll down, I can see the results of the chi-square test. So again, we are looking for the Pearson value for the chi-square, not the likelihood ratio. So the Pearson value is 76.168. Remember that if you need more digits after the decimal point, click on the box to highlight it, click on the drop-down arrow, and you can change the number of decimal places. So if I want 4 decimal places, I can get that. I can do the same thing for the p-value to change that to 4 decimal places as well. So my results here, my chi-square, which remember is the fancy x, my chi-square value was 76.1681. And my p-value was 0.0000. Remember, this is Pearson up here to pick the right one for the homework. So, p-value, compare that to alpha. It doesn't matter what alpha I use. In this case, I want to use 0.05, but if it's 0, it's going to be less than alpha. So since p is less than alpha, this is alpha right here, reject the null hypothesis. So, what can I conclude? I conclude that there is a relationship between the gender and funding source, gender of the yearbook editor and funding source of the college. Or in other words, that they are not independent.